Thank you, Lisa. And good morning, everyone. Yeah, I used to be a teacher, and it's customary for class to answer their teacher. So, good morning, everyone. Good morning. I like that. So, Lisa has asked me to talk about the environmental impact of textiles, which I will do. It's a topic that's very near and dear to all of our professional hearts, as it is one of the ways that we can measure our impact. But first, it's a great privilege to speak in front of such a qualified audience with a lot of professional expertise and experience. It is also a source of some unease. And therefore, I thought that I would distribute some of that unease a little more evenly in the room by letting you know that I'm right now picturing all of you naked. And if you think, oh, not me, then you should know I don't discriminate. So I think it's worth reflecting on our moment in time. We are fortunate to live at a very remarkable moment in time. It's an extraordinary moment. This meeting may not be possible at any other time. Almost the entire globe is livable. It's home to an incredible diversity in species, flora and fauna, in cultures, in languages. Here represented in this room, as we heard, are many different nations, cultures, languages. Take travel. Most of us had to board a plane and fly for a few hours to get here. A generation ago, or two or three, this would not have been possible. It would have been prohibitive, cost-wise. It would have taken us weeks to gather here, and some of us may not even have made it. And granted, we know we are part of a privileged minority who have the possibility of traveling and seeing the world and learning from and of people. There are many who don't have the possibility or the access to do this. But the technology is here. We are able to do it. We are today 7.4, 7.5 billion people on the planet. And if we look back 100 years, we were only 1.7 billion. That's an astounding growth. But as you can see from the red curve, our annual growth rate has been dropping since the 60s. So world population would level off at around 11 billion at the end of this century. People are healthier than ever before. This graph shows all the countries, the way the world looks today. On the horizontal axis, we have income, wealth. Further to the right is wealthier, further to the left is poorer. On the vertical axis, we have health, represented by life expectancy. And if we look 100 years ago, all the countries were in the bottom left. There was no country in the world that had a life expectancy above 40 years. Today, every country in the world has a life expectancy higher than 40 years. And as you can see, most of the people are living in the middle. We have some countries in the top right, very healthy and wealthy. It's mostly European countries, the US, Canada, some Asian countries. And then we have many African countries in the bottom left, where people are poorer. The size of each bubble represents the population of each country. At this moment in time, more people are able to read and write than ever before in our history. On this graph, you can see that in 1800, the illiteracy rate was 88%. Only 12% were able to read and write. And it didn't change much in the first 100 years. So in 1900, illiteracy was still 80%. But in the last 100 years, we've gone to a literacy rate of 85% globally. This is a remarkable achievement. People are also more connected than ever before. 3.7 billion people, or half the world's population, use the internet. As you can see here, there are more people using the internet in Africa today than in North America. This gives us a whole new realm of possibilities for a globally connected world. Planet Earth has been around for about 4.5 billion years, and was only shortly after the oceans formed and the planet cooled down a little bit that life started. But for most of these 4.3 billion years of life on Earth, it's been single-cell organisms. It's only in the last 600 million years that we have had multi-cell organisms. The first hominids appeared on the scene 2 million years ago. That is 0.004% of Earth's history. Modern humans succeeded in cultivating and populating most of the planet in the last 12,000 years. And in the last 250 years, and in particular since the middle of the last century, human activity has become the dominating influence on the Earth's climate and environment. Geologists have coined a term for this, and they call it the Anthropocene. And when we talk about the Anthropocene, we're really talking about the era starting around 1950. So it's very recent. So this period that we live in, if we now say modern human civilization, it is a mere instant in the lifetime of the planet. You could say that we are a fart in space. That is how my grandmother liked to talk about, not people, but insignificant things. I'm not saying we're insignificant, but our moment is. My grandma, she was born about 100 years ago in Sweden, at a time when most Swedes were poor and unhealthy. And this is not 100 years ago. But yours truly is sitting in the corner there in front of the beautiful brown curtains. The same year that my grandma was born, another Swede, Svante Arrhenius, was inducted in the American Academy of Arts and Sciences. This is the entrance to the Academy in 1912 on Newbury Street in Boston. This is the entrance. Today, it's now a banana republic. But the Academy lives on. It was founded in 1780 by some of the founding fathers of this country. And the purpose is to promote the arts and the sciences. Svante Arrhenius, he had just a few years earlier published a book. It's called Worlds in the Making, where he made the case that increasing carbon in the atmosphere was leading to a warmer climate, and that by continuing to put carbon in the atmosphere, we could avoid another ice age. At the time, a little bit of warming was looked at as a good thing. This was in Sweden. He was a chemical physicist, and he developed a rule that is still in use today for measuring how much warming you can expect based on how much carbon you put in the atmosphere. That was a little over 100 years ago. The natural greenhouse effect is what makes life on Earth possible. But at this moment in time, we are putting out carbon in the atmosphere at an astounding rate. And this is what's creating the additional warming. So the concentration of greenhouse gases, that's the light blue line here, and the average temperature on Earth is the dark blue line. And this is a period starting from 1880, when the concentration of CO2 was around 280 parts per million. That's what it was for most of humans' existence on Earth. But since then, as you can see, it's been growing and it's been accelerating. In 1985, we passed the safe level of 350 parts per million, sorry. Beyond 350 parts per million, we are insured to get global warming. Last week, we passed 410 parts per million, and we are now growing our carbon concentration in the atmosphere by 2.5 parts per million per year. That's up from 2 parts per million 4 years ago. The last time that we had this much carbon in the atmosphere was more than 10 million years ago. There were no humans on the planet. It was 11 degrees Fahrenheit warmer, and the oceans were 100 feet higher. So this is a temperature map of the world that shows higher than average or lower than average temperatures. Blue is lower, red is warmer. And as you can see, as we get into the second half of the 20th century, and especially into the 80s, 90s, and then the last couple of decades, it gets warmer and warmer. And 2015 was the hottest year ever until 2016, which is now the hottest year ever. And this is having real impacts. An estimated 400,000 people die every year from climate change-related issues. And we hear about the disasters, but what we don't hear about is what kills most people. And those are malnutrition, diarrhea, and malaria. And primarily it's people in sub-Saharan Africa and South Asia who are affected, and 90% of the people who die are children under 5. Today we also have more people displaced in the world than ever before, more than 65 million people. This would be a very large nation if it was a country. These are people who have fled their homes for various reasons, many of them because of climate change. In fact, in the last 6 years, some 140 million people have left their homes because of climate change. This is expected to increase so that by the middle of this century, 1 in 30 humans may be displaced because of climate change. That would be somewhere between 250 and 300 million people. So this gives us, and we are of course part of the privileged few who feel less the impact of climate change. But it doesn't exclude us from the moral obligation to do something about it. Also because we are the ones who can do the most about it. The people who are affected are not the ones who are emitting most of the carbon. So what can we do? Well, actually, we have all the solutions. First, we have to shift energy production from carbon to renewables. We have to put a price on carbon. And this is not some fake price. This is the real price, the cost to society of emitting all that carbon. Make the polluters pay. Then we have to restore our soils. A living soil is an enormous sink of of carbon, organic matter. Soils that are cultivated with fertilizer and pesticides kill all the microorganisms in the soil. The soil turns dead unless you put new inputs, the fertilizer, into the soil, nothing can grow. We have an enormous potential in capturing carbon from the atmosphere by rejuvenating our soils. Plant trees, it's obvious. Plant trees because they suck up carbon from the atmosphere, and especially if they're planted in the tropics, in warmer climates where they grow faster. And then finally, eliminate waste. Reuse, recycle, and compost. And that's what I'm going to talk a little more about. So textiles is some of the stuff that contributes most carbon emissions to the atmosphere. The textile industry is responsible for 10% of the global carbon emissions. According to Eileen Fisher, a very upscale clothing brand, big textile is the second dirtiest thing in the world to big oil. And no wonder, because the textile industry puts out 150 billion new garments every year. So in order to find out what the environmental impact of our textiles is, we have to do what's called a life cycle analysis. And what that is to look at the life of a garment, for example, any kind of product, and what the environmental impacts are at each stage. So for a piece of clothing, you would look at the material, which is the growing or production of the fiber, the production of the clothing piece, the transport along the way, and then the use phase when we are actually wearing it and washing it, and finally the disposal. So this is one such study. It came out last month, and it looked at clothes consumption in Sweden. The conclusion is that 70% of the climate impact is from the production phase. So it's everything from growing the cotton until you have a finished garment. The distribution is a minor impact. That's when the clothing is shipped halfway around the globe. Another big impact is the consumer transportation. That's when we get in the car and drive to the mall. That was a little surprising. And then the use phase, the laundry, is not a big impact. What this study also concluded was that the consumption of textiles is the fourth largest contributor to carbon emissions in Sweden after, I will check my notes, transport, food, and housing. And they say that this is likely the same in the rest of Europe and in the US. So we're halfway there. Do we have any meerkats in the audience? I've been taught you should check in with your audience every now and then. We're gonna make it. We're gonna make it. Okay, so of course different fibers, different materials have different environmental impacts. So let's take cotton. Cotton is in 40%, almost 40% of our clothes. And it has a very clean image, but actually there is a dirty truth behind it. It's a very thirsty plant, and it's one of the most chemically dependent plants on the planet. So while only 2.4% of the world's cropland is planted with cotton, it consumes 10% of all agrochemicals and 25% of insecticides. So let's look a little bit at how cotton is grown. There is evidence that cotton cultivation started in Mexico as early as 8,000 years ago, but consistent production of cotton started about 7,000 years ago in the Indus Valley. And some of the methods that were developed at that time have been in use until very recently. Cotton has actually been grown pretty much the same way since 7,000 years ago until about 65 years ago. So this is cotton being picked in Oklahoma in the 1890s. This is cotton being picked in Georgia in the 1940s. And this is weeds being removed from a cotton field in Georgia also in the 40s. And then it changed after the Second World War. The chemical industry that had been producing poisons to kill people during the war found out that those same poisons also killed other living organisms, and the agrochemical industry was born. And the agrochemicals were first introduced in mechanized agriculture in the 50s and 60s, but more recently also in developing countries. So in Pakistan, in the Punjab province, as recently as 1983, only 5 to 10% of the cotton crop was sprayed with pesticides, but now 95 to 98% are using agrochemicals. Where is cotton grown? Well, in tropical and subtropical areas all around the globe. The biggest growers are China, India, and the United States. And the US is actually the largest exporter of cotton in the world because we don't have much domestic textile industry anymore. So a little bit about cotton cultivation in India. India is home to 1/3 of the world's cotton farmers. These are not large plantations. In India, cotton accounts for 54% of all pesticides, despite occupying only 5% of land under crops. Children are directly involved in pesticide application. India's 10 million cotton farmers work in a highly unsafe work environment. People work barefoot and barehanded, wearing only traditional sarongs. Concentrated chemical products are mixed with water using bare hands. Severe water scarcity in India is exacerbated by the cotton industry. Producing 1 kilogram of cotton in India consumes 22,500 liters of water on average. The global average water footprint for 1 kilogram of cotton is 10,000 liters. The far higher water footprint for India's cotton is due to high evaporation and high rates of water pollution. In 2003, Indian researchers tested 16 brands of bottled water for traces of pesticide residues. 14 brands tested positive for chlorpyrifos and 1 for dimethoate, both chemicals commonly applied during Indian cotton production. So here's the results from one life cycle analysis study that was done in 2009. It's a cotton t-shirt produced in India and used in Germany. So the water to produce one cotton t-shirt, 1,320 gallons, or per pound of t-shirts, 2,400 gallons. We have fertilizers, pesticides, fossil fuels. CO2 emissions are 16.3 pounds per pound of textile. And then we have other gases. Let's look at another material, synthetics. So polyester and nylon are made from oil And that takes a lot of energy. Nylon, in addition, emits a gas called nitrous oxide during manufacturing. And this gas is 300 times more potent than carbon dioxide in terms of global warming. Another problem with synthetics is that microfibers shed from the clothing as we use them. And this, the shedded microfibers account for 85% of the human-made material found along ocean shores. The carbon impact of a polyester jacket, this one made in China, used in Germany, is 15.3 pounds per pound of clothing. So how can we reduce the environmental impact? In many ways. This is one way we know. Pick your color bin and drop off your clothes. And reusing and recycling material replaces new manufacturing. If you're dropping off your clothes, approximately 80% will be reused, either as clothing or rags, 10% recycled, 10% waste. So, if we now look at the cotton t-shirt representing our natural fiber materials and the polyester jacket representing our man-made fiber materials, and we apply the ratios of each that we consume, we can get a blended average of our carbon emissions. And that is 15.7 pounds saved. But then we have to take into account that the cotton that we're not growing, because we're reusing that cotton t-shirt, would have absorbed some carbon from the atmosphere. So the net, and we're also emitting some carbon when we collect and distribute the used clothing. So the net savings are 14.7 pounds per pound of textiles. So how does that stack up against other recyclables? Well, it fares pretty well. So this is comparing to glass, plastics, and paper, and aluminum. The only material that can compare to textiles is aluminum. Another benefit, it's not an environmental benefit directly, but it is that importing used clothes creates jobs. Another study that was just published last week, this is from last year. It states that for every, actually 18,000 pounds, that's a typo, 18,000 pounds of clothing imported, one local job in sorting, wholesale, and retail is created. And that does not even take into account logistics jobs and informal sector employment, which we know is very big. So that was reuse. Another possibility is that we look at the fibers that we use, and one option is to grow cotton organically, without pesticides, without fertilizer. Today, this accounts for less than 1% of the cotton that's produced, but the benefits are just excellent. Even though it still uses a lot of water, it's significantly less from when you grow it, what do you call it? Yeah, whatever. So, and the water savings, that's a big deal because 20% of industrial water pollution around the world is from the textile industry. This is a river in Bihar in India, an area where there are a lot of dying plants. And this discolored, polluted water is seeping into the groundwater. It's polluting wells and making people very sick. Levi's, they have introduced what they call waterless jeans, where they have changed their finish process. So you want those really worn-looking jeans, but you don't want to use a lot of water. So they use some other methods to finish the garments, and it's saving a lot of water. This is very exciting and promising, I think, because the dyeing process is such a big polluter. Here are 3 companies that have developed different processes for dyeing fabrics without using a lot of water, without using a lot of chemicals. The limitations are that it's limited what types of fabrics can be used with each process, and the equipment is very expensive. Some companies are also reclaiming or recycling fibers. So you take an old cotton t-shirt, you break down the fiber, and you make a new cotton t-shirt. And Patagonia, they also reclaim wool and recycling nylon and down. Then there is Bionic and Reprieve Yarn. So this is recycling of plastic bottles. Maybe you have seen, maybe you have one of these shirts that's made from PET bottles. This is a good one, linen. It's a natural fiber. It's been around as long as cotton. It's lightweight, it's durable. It's even more durable than cotton, and it's much more gentle on the environment. Much less water, pesticides, and energy needed to produce linen clothing. So let's compare different fibers and the carbon impact from each. As you can see here, leather is by far the biggest contributor. So this is kilograms of carbon emissions per kilogram of garment. Wool is also a big contributor. 80% of that is from the methane that the sheep emit. Nothing more about that. And yeah, then you have cotton, you have other man-made fibers like cellulose, which is made from wood. Viscose, rayon are the names of the fibers. And then you have synthetic, and the lowest one is silk and linen. So this is the carbon emission from the fabric production. In order to look at what you're potentially saving by reusing one of these items, you would have to add another 2 kilograms. And that's for the transportation, the packaging, the administration. So, in conclusion, we need to get away from our wasteful, from extraction to disposal economy, and work on creating a circular economy where we take care of our resources, we reuse them, we recycle them, and this is how we can save a lot of greenhouse gases. In the US, 40% of greenhouse gas emissions are linked to the waste economy. And important to note is that textiles contribute more greenhouse gases per pound than most commonly recycled materials. And, as we know, they are easily reused and recycled. So let's make the most of this very remarkable moment in time and be more significant than a fart in space. So. Any questions or comments? So I should announce that in the break there will be, in one of the later breaks, I think, when we have the exhibitions, there will be a quiz in the USAGAIN. Yeah, and so all the questions are in this presentation. Okay. I was supposed to announce that before, but... Okay, now you know.
There's a question down there.
Okay, thank you.
Need to get it. Wait 2 seconds.
Okay.
There is a question.
Hi, thank you. That was an incredible presentation. You covered like everything that what's on my mind. I'm just curious, and there is obviously I don't think there's a right answer to this question, but like, what do you think about the impact of fast fashion on a lot of the curves you were showing? And what are some ways, or do you know of any brands or retailers out there that are really promoting different consumption alternatives, I guess?
Okay, thank you. Good question. So fast fashion is really what's driving this global pollution. And the reason why Eileen Fisher says that textiles are the second largest polluter after oil is because of fast fashion. The consumption of textiles has increased sixfold since the 80s. And that's just astounding. And you know, you have some of the brands, H&M, the biggest clothing retailer in the world today. The store is new every week, in some cases every day. You know, they're bringing in new products. And that is what's driving this. And what can we do? I mean, one thing we can do is to be mindful about what kind of clothing we consume and go for more durable clothing, things that will maybe not, that will stand the test of time, and something that will last, has a much lower carbon impact than something that we throw away after a month. So that is an action we can take. And yeah, I'm not so good with what brands to pick, and so on. Some brands were mentioned in the presentation, but I would encourage you to do your research. And the good thing is that more and more people are becoming more conscious about this. So this is actually driving brands to look for ways to be more environmentally responsible. So I think this will change a lot in the next few years. Thank you.
But wouldn't that be just natural fibers? Like polyester fibers?
Yeah, that would be my... So the question is, would that be just natural fibers and not the polyester synthetics? And I mean, personally, that's what I think. I think the synthetics are harmful in so many ways because of the pollution in creating them, because of the extraction, because of the chemicals, and and they're not biodegradable.
But there's a limit on natural fibers.
Is there a limit on natural fibers? Such as wool, cotton crops?
Wool is maybe challenging, but materials such as jute or linen, for example, that's a very sustainable. Flax, hemp, these are all natural fibers that could be scaled up.